All right, let's jump right in. We're going to head way out to the orbit of Saturn, to a tiny little moon called Enceladus. Now, on the surface, it looks like a bright, icy world. But according to the material we're looking at today, this little moon holds a puzzle so big it might just challenge everything we think we know about how light and heat work in space.
So, here's the first clue. Enceladus has what's called a bond albedo, which is just a fancy way of saying its total reflectivity of over 99%. To put it simply, that makes it one of the absolute brightest, most reflective objects in our entire solar system. It's like a perfectly polished cosmic mirror. Now, to really understand how wild that is, let's compare it to things we know. Fresh, clean snow here on Earth reflects about 90% of light. But Enceladus, which we're told is covered in ice, reflects more than that. The source we're looking at basically says, hang on, that shouldn't be possible. How can an icy surface be brighter than perfect snow? And that, right there, is the mystery we're diving into.
So that brings us to our first big point. We're going to take a closer look at this impossible brightness and the incredible speed of this tiny moon.
The author we're covering puts a really radical idea on the table. What if Enceladus isn't just reflecting sunlight? What if it's actually making its own light? And what's powering it? Well, they point to its unbelievable speed, whipping around Saturn at almost 60,000 kilometers per hour.
Okay, so if it's not reflection, what in the world could it be? Well, that takes us to the next section and the source's proposed solution. A brand new theory about the very fabric of space itself.
At the heart of this theory is a concept the source calls a charge field. Now, the idea here is that empty space isn't really empty at all. Instead, it's filled with a kind of cosmic soup of tiny spinning particles, photons and what they call antiphotons, all spinning in opposite directions.
So here's how it supposedly works. You have a moon, like Enceladus, just rocketing through this field of particles. The theory says that the photons coming off the moon crash into the antiphotons that are already in space. Their opposite spins cancel each other out, and boom, that interaction releases a burst of energy as both light and heat. The source even has a name for it, photon friction.
Now here's where it gets really interesting. The author claims this one single theory doesn't just explain what's happening with Enceladus. They argue you can use it to solve a whole bunch of other cosmic mysteries that have left scientists scratching their heads.
Let's start with something a lot closer to home. Our own moon. I mean, think about it. It's incredibly bright, right? And its surface can get absolutely scorching hot. But there's no snow, no ice, and no atmosphere to trap any heat. So what's going on?
Well, according to this theory, the answer is exactly the same: photon friction. You see, the moon has a really high compound velocity, around 40 kilometers per second, because it's not just orbiting the Earth, it's also being carried along as the Earth orbits the Sun. All that speed, plowing through the charge field, is what this theory says makes the moon way hotter and way brighter than it has any right to be.
And this quote from this source really gets to the heart of the paradox. See, conventional physics seems to demand two opposite things at once. To get that hot, the moon should be black, so it absorbs tons of energy. But to be that bright, it should be white, so it reflects tons of light. The author's point is, you can't have it both ways unless something else is generating that heat and light.
All right, let's go to the outer solar system. We have Uranus, an ice giant, way out there, almost 3 billion kilometers from the Sun. So why on Earth is its upper atmosphere hotter than the surface of Mercury, the planet that's literally right next to the Sun?
And the difference here is just staggering. Standard models predict Uranus's atmosphere should be unbelievably cold, like below minus 220 degrees Celsius. But what we actually measure is 850 Kelvin. That is a gigantic, unexplained gap between theory and reality.
The author says, forget solar heating. What we're seeing is a charge fire. The very top of Uranus's atmosphere is the first thing that slams into this ambient field of particles, and that collision, that friction, creates this intense heat right at the boundary.
So for our last puzzle in this section, let's go back to Saturn. We all know about its amazing rings, and there are moons actually inside them. But here's the really weird part. Our moon Enceladus is actively creating one of the rings, the E-ring, but its neighbor, Mimas, does the exact opposite. It clears a huge gap. How can two nearby moons have completely opposite effects?
The source argues that gravity alone just doesn't explain this. Instead, the theory suggests that Enceladus is getting sanded down by this charge field.
and that's what's creating all the debris for the ring. MIMOS, on the other hand, is proposed to be charge neutral, or, and the author admits this is a bit unclear, upside down in its charge, which somehow causes it to push away ring particles, clearing a path.
All right, let's move on to what is probably the most provocative, most shocking claim of this entire theory. It suggests that if Enceladus is making its own light, well, maybe it's not the only one, and maybe the entire way we measure brightness in space is just wrong.
So to get this, we have to understand a specific term called geometric albedo. Now, this isn't about total reflectivity. It's basically a comparison. You measure how bright a planet or moon actually is, and then you compare that to a perfectly flat, perfectly white, idealized disk of the same size. It's a standard tool in astronomy.
The officially measured geometric albedo of Enceladus is 1.4. And here's the thing. According to the standard model of light and reflection, that number should be physically impossible.
And here's why. A score of 1.0 would mean it's a perfect reflector, just like that idealized white disk. So anything over 1.0 means the object is somehow sending back more light than it's getting from the sun. An albedo of 1.4 means Enceladus appears to be reflecting back 140% of the light that hits it.
This seems to just shatter one of the most fundamental laws of physics we have, the conservation of energy. You can't get more energy out of a system than you put in, period. Unless the object is actually generating its own energy.
And this leads to the author's most serious accusation. They claim that mainstream science knows about these impossible numbers, not just for Enceladus, but for many celestial bodies, and that the albedo calculations are deliberately made complicated to, in their words, fudge the math, and hide the fact that these bodies are generating their own light.
This brings us to the source's final, startling conclusion, that what we're taught as physics isn't really a search for truth, but has become an institutionalized system for suppressing it, all to protect a worldview that might just be fundamentally flawed.
So what do we do with all this? The source material we've gone through today puts forth this really wild picture of the cosmos, one where planets and moons aren't just passive rocks reflecting light, but are active engines generating their own light and heat. Now, while it clashes with so much of established physics, it does leave us with a pretty fascinating question to think about. If we even entertain this idea, what other fundamental forces of the universe might we be getting completely wrong?